we are going to learn about rockets. We use many devices like television, phones, maps, GPS navigation system, etc. All these things are working because of these satellites. You can call or message anyone around the world within a fraction of seconds by the use of satellite signals. You can go anywhere around the world by the use of navigation system. And by watching television, you get to know what's happening in the world, and you can watch any program, and we know climate change, how the other planets look like, and we even traveled in space and landed in moon. And today, the Voyager, that is a space probe, has reached the interstellar, that is a region outside our solar system where sun's magnetic field stops. So all these things are happened because of the rocket. Because without rocket, we can't launch satellite, space or human spacecraft. So what is a rocket? A rocket is a spacecraft, aircraft, vehicle or projectile that obtains thrust from rocket engine. Rocket engine exhaust is formed entirely from propellant carried within the rocket. Now let's see about the history of rockets. The first rocket was made in China 800 years ago. They used it as fire arrows, which has gunpowder tube that is attached to a arrow, which is used as weapon in battles. Then it is also used as fireworks. Then the European countries starts to make fire arrows. Then it spread to many countries. The fire arrows are made up of wood or bamboo sticks. Then Tipu Sultan invented the first iron case rocket in 1792, which is used in the battle, and Tipu Sultan defeated Britishers using it. During that time, it is only used as weapon. But after that, Konstantin Tsiolkovsky and Russian scientists brought up the idea of using rocket as a device to explore space by publishing a paper called Exploration of Cosmic Space by the means of reaction devices. Then the first liquid fueled rocket is invented by Dr. Robert H. Goddard, the father of rocket, which was launched on March 26, 1926. Now let's see about the parts of the rocket. The rocket has four important parts. One is structural system, payload system, guidance system, and propulsion system. Now first let's see about the structural system. The structural system is the frame that covers the rocket. It is made up of very strong but lightweight material like titanium or aluminum, and the fins are attached to the bottom of the frame to provide stability during flight. Next, payload system. Payload is the object that the satellite is carrying into the orbit. Payload depends upon the rocket's mission. The rockets are modified to launch satellites with a wide range of missions like communication, weather, monitoring, planetary exploration, and special rockets are also developed to launch people into the Earth's orbit and onto the surface of the moon. Next, guidance system. Guidance system guides the rocket in its path. It may include sensors, onboard computers, radars, and communication equipments. Next, propulsion system. It takes up the most of the space in a rocket. It consists of fuel tanks, pumps, and combustion chamber. There are two main types of propulsion system, that is liquid propulsion system and solid propulsion system. Now let's see about how rockets are working. To push the rocket upwards from the ground, enormous amount of force is required. By applying the Newton's third law of motion, that is, every action has the equivalent and opposite reaction, we can achieve that force. That where the rocket engine comes into play. The rocket engine works by burning either a solid or liquid fuel in the presence of an oxidizer. When the combustion reaction occurs, it throws out a great deal of mass as a byproduct of the reaction. This byproduct are released at great speed through the bell-shaped nozzle that you can see at the bottom of the rocket. Since the rocket pushes the exhaust down, the exhaust responds by pushing the rocket up at a great speed as well, which lifts the rocket off the launching pad and propels it upwards. And then the rocket shoots upwards by throwing hot gases from its exhaust. You could have noticed that during a rocket launch, rocket does not maintain a straight path all the way up. It lifts off perfectly vertical, but after some time, it starts turning and going laterally. This is known as the gravity turn. This technique employed during launch because it offers two benefits. First, it uses gravity to steer the rocket onto the desired direction. It helps to save fuel. Second, it helps to minimize aerodynamic stress on the launch vehicle. If a rocket continued to go up without tilting at all, it could reach a point where it could run out of fuel. That's why it tilts slightly after lifting off straight up. And once the rocket lifts off, part of it are sequentially separated at predefined intervals. The staging system is used because the amount of fuel it takes to launch a rocket is so high. So they are using staging system. Once a stage has emptied out of all its fuel, it detaches from the rocket and returns to Earth, so that the second stage can keep going without having to drag along the extra weight of the empty fuel tanks. Now let's see how the satellites are orbiting the Earth without falling down. Now let's see an example to understand it better. Now imagine you have a ball which is tied to a rope. When you circulate the rope, the ball will spin fastly along with the rope without falling down. The same thing is happening here. Satellites are able to orbit around the Earth because they have momentum which was provided by the rocket. The initial speed of the satellite maintained as it detaches from the rocket is enough to keep the satellite orbit for 100 years. The satellite orbiting the Earth by balancing two factors: its velocity and the gravitational pull that the Earth has on it. A satellite orbiting closer to Earth requires more velocity to resist the gravitational pull. Now let's see about the first rocket launch in India. The first sounding rocket launched in India on 21st November 1963 at Tumba near Thiruvananthapuram, Kerala. And all the parts of the rockets are brought up by the scientists by using cycle and bullock carts because Tumba does not have any facilities. The rocket is launched from Tumba because Vikram Sarabhai thought it is a good place to launch a rocket because it is ideal for lower altitude, upper atmosphere and ionosphere studies. Now let's see the launch vehicles of India. First, SLV. SLV, that is Satellite Launch Vehicle, was the first India's first experimental satellite launch vehicle which has 4 stages. Second, ASLV, the Augmented Satellite Launch Vehicle, it has 5 stages, all solid propellant vehicle. Next, PSLV, that is Polar Satellite Launch Vehicle. It is the Indian launch vehicle to be equipped with liquid stages. Next, GSLV, that is Geosynchronous Satellite Launch Vehicle. It is the largest launch vehicle developed by India. This has 3 stages. Next, GSLV Mk3. It is chosen to launch Chandrayaan-2 spacecraft. It has 3-stage heavy lift launch vehicle developed by ISRO. Now let's see the launch vehicles of NASA. First is Saturn V. Saturn V was an American human-rated super heavy lift launch vehicle. It has a stage liquid-fueled rocket. It developed under the Apollo program for human exploration of the moon and was later used to launch Skylab, the first American space station. Second, Space Shuttle. It is retired, partially reusable, low Earth orbital spacecraft operated from 1981 to 2011. It used carry astronauts and cargo to and from Earth orbit. Next, Titan Centaur. It was an American expandable launch system which has used as high-profile NASA mission, including Voyager and Viking planetary probes. And it is launched 7 times between 1974 and 1977. Next, Atlas Agena. It was an expandable launch system used to launch the first 5 Mariner uncrewed probes to the planet Venus and Mars and the Ranger. Next, Redstone. It was the first large American ballistic missile. It was the first US missile to carry a live nuclear warhead. So that's it for today. Thank you.